Here's today's warm-up. The number of square units in the area of a square is greater than or equal to the number of units in the perimeter of the square. True or false? Well, it's false because it's asking which side length provides a counterexample to the statement. Don't put your answer yet. Answer to the warm-up is D, yes. Counterexample means you make the beginning true and the ending false, right? So we want, this one doesn't quite work the same way because it doesn't really have a hypothesis and a conclusion, but we want the perimeter to be greater than the area. Well, yeah, the perimeter to be greater than the area. So if a square has side lengths of 2, the perimeter is 8. The area is 4. And that's the only one where it turns out that way. The rest of them, the area is bigger. The area is usually bigger unless your side gets as small as 2. Okay? First, I'm going to show the answers to a worksheet you had a couple of nights ago. I haven't shown this on a recorded lesson yet. Trapezoid, rhombus, kite. Trapezoid, rhombus, kite. So we're going to work 4 and 19. Number 4, maybe? There we go. Number 4, we had one just like this in the notes. Number 4 gives you the mid segment, which is a little bit tricky, but since we went over this in the notes, it shouldn't have been as tricky. So on number 4, you know the height, right? The height is 10. The area formula is base 1 plus base 2 times the height divided by 2. Well, from last unit, the area of a mid-segment, not the area of a mid-segment, the mid-segment is base 1 plus base 2 divided by 2. That's what 14 is. It's the average of the bases. So since 14 is the average of the bases, you can simply plug it in for this part of your formula. So the area is just literally 14 times 10. Because base 1 plus base 2 divided by 2 is 14. So you're substituting, okay? So that's how we get 140 on that one. Cool? Number 19. Miss Gray pays 15 cents per square foot to lease space at a shopping center. Each store front is 50 feet wide. So each one of these is 50. Okay. Find the monthly cost for her to lease store C. What shape is store C? It is a trapezoid. Okay, so how do you find the area of a trapezoid? Well, base 1 plus base 2 times the height divided by 2. So you had to turn your head sideways to find the bases. They're the ones that are parallel to each other. Okay, so base 1 plus base 2 times the height, which is 50, divided by 2. So 170 plus 50 divided by 2, 0.15. $637.50 to rent out storefront C, to rent out store C. How much does the owner receive each month if all the stores are leased at this rate? So we need to find the area of each store. So we'll do 70 times 50, 3,500, 3,500. What about this one? 5,000. That one's a big store. So now we're going to add them up. 5,000 plus, we already found this one, 4,250 plus 3,500 plus 3,500. We get 16,250 square feet, and then we're going to multiply that by the going rate, which is 15 cents per square foot, and so that person's going to make $2,437.50 per month for leasing those out. Okay, any other things from the homework? You could live off of that. Area and perimeter of regular polygons. So get your notes out, get your little formula chart thing out, And we have to go over some vocabulary before I can teach you the formula, because this stuff is probably new to you. So title it Regular Polygons. What did it mean if a polygon is regular? Because, by the way, this formula that I'm going to show you only works on regular polygons. If you get a polygon that's not regular, you'll have to turn it into other shapes and find the area of the other shapes. Are we doing the radius thing? Yes, we are. How do you already know about that? Okay. So a regular polygon is a polygon that has, let me go back, sorry. It's a polygon where all sides are congruent and all angles are congruent. So this is only going to work when our polygons are regular. So would this formula work on an isosceles triangle? No. Would it work on an equilateral triangle? Yes, because an equilateral triangle is a regular polygon. Okay. Now, you don't actually have to do this. I'm just going to show you how you would draw these things. I'm not sure if you've seen these words before. Draw an equilateral triangle inscribed in a circle with radius 10. Do we know, get the patty paper, do you know you don't actually have to do it with a compass? It doesn't have to be exact. We're just sketching. I should have put sketch instead of draw. Do you know what inscribed means, or could you guess? What does inscribed kind of sound like? Good, inside. Okay, maybe we have gone over this. So that means draw a triangle inside a circle with radius 10. So I have my circle, I have my triangle, and then the radius of the circle is 10. So that's what that picture would look like. Draw a square circumscribed about a circle with radius 10. So if inscribed means inside, then what do you think circumscribed means? Oh, you guys with your Illuminati. Yes, it means outside. So we want a square outside a circle, harden my circle, with the circle as a radius of 10. Okay? So that's what these two would look like. This is probably making no sense right now. You don't know why we're talking about this, and that is okay. So remember, we're doing circles tomorrow. Well, nope, we're doing circles Friday. But remember that a radius of a circle goes from the center to the circle, to the outside. Okay? So that's what this would look like. Now we're going to come back to this and talk about what this means for our polygons. Okay? So I just wanted you to know what inscribed looks like and what circumscribed looks like. Notice how the vertices of the triangle are all three on the circle. And here, notice how the circle is touching the square all 4 times. Touches it, touches it, touches it, touches it. So you can't just draw a circle inside a square. You can't just do this. That's not inscribed. That's not circumscribed. They have to be touching. They have to be tangent, which we'll talk about in a different unit. Okay. Enough chatter, Miss Tanton. All right. What is a regular polygon? We kind of already talked about that. You don't need to write this in your notes if you remember it. It is a polygon with all sides congruent and all angles congruent. Next word might be new to you. It's called an apothegm. Some people pronounce it apothegm, but to me that sounds like an animal, like a possum. Anyways, it's kind of like potato, potato. You can pronounce it either way, but I think the more preferred way is apothegm. So I'm going to call it an apothegm, but if you want to say apothegm, I won't really mind. The apothegm is the distance from the center of the polygon to a side. It is the distance from the center of the polygon to a side. Is it from the center to an angle? No. It's the distance from the center to the side. Yes, you need to write this down in your notes somewhere. The next word is a radius. Now, you've learned about the radius of a circle, but did you know that polygons had radii too? So there is such thing as a radius of a polygon, and it's pretty much similar to the radius of a circle. So what is the radius? It is the distance from the center of the polygon to a vertex. I'm going to go back up to my apothem one. It's the perpendicular distance, so I am going to add a 90 so that we know that that's 90. So we start at the center of the polygon and we go to a vertex, and that is the radius. So if we go back to this picture right here, notice in this picture, the radius of the circle is the radius of the triangle. The radius is the radius. But in this picture, the second one, the radius of the circle is the apothem of the square. The radius of the circle is the apothem of the square. I'm just pointing things out to you. Don't get overwhelmed. I'm just showing you how these things work, okay? So I'm going to take a regular, what is this? Pentagon. I'm going to take this regular pentagon, and I'm going to draw a circle inscribed, and I'm going to draw a circle circumscribed. I'm going to show you what happens. So here's a circumscribed circle. And here is an inscribed circle. There we go. Notice that when I draw both the circumscribed circle, where the radius equals the radius, and the inscribed circle, where the radius equals the apothem, what do you see right here? It forms a right triangle. So the radius and the apothem and half of the side always form a right triangle. So if I were to pull that triangle out, I would have radius, I would have apothem, and I would have 1/2 of a side of my polygon. Okay? Okay, this will make more sense later. So, if I drew an equilateral triangle, and I drew the radius and the apothem, what kind of triangle would I have there? What are the angles of an equilateral triangle? 60, 60, 60. But if I bisect 60, I get 30, 30, 30. If that's 30 and that's 90, then that's 60. So this is called one of our special cases. It's a 30, 60, 90 triangle made up of the radius, the apothem, and half of the side. I'll summarize these, so don't write them down yet. A square is also a special case. What kind of triangle is that if I draw the radius and the apothem? It's a 45, 45, 90. Good. Cool. And, ooh, regular hexagon made the list. He's special too. What kind of triangle do I get when I draw the radius and the apothem of a regular hexagon? So, you could actually find the angles of a hexagon, remember? N minus 2 times 180 divided by n. Ooh, that's old formula. Dust that formula off. So, I promise, just trust me, you'll get 120. Well, when you cut 120 in half, you get 60 and 60. So, it also forms a 30, 60, 90 triangle, except the 60 and the 30 are in different places that they were in the equilateral triangle. So, here's all three situations summarized. I'll let you stare at that for a minute, and then we'll actually get to the area formula. So these are what we call these special cases. They are special. Okay, we're actually not going to derive the formula. I'm so sorry if I'm disappointing you. I'm just going to give the formula to you. The area of a regular polygon is right here. The area equals apothem times perimeter divided by 2. The lowercase a stands for apothem. The uppercase a stands for area, so make sure you don't get those confused. Perimeter is always capitalized, so it's apothem times perimeter divided by 2. What does that look like the formula of? Like a triangle, yeah. Base times height divided by 2, because you can divide a polygon up into triangles. So it is really similar to a triangle. Base times height divided by 2. Apothem times perimeter divided by 2. You don't really need a formula for the perimeter. You know you take how long each side is and multiply it by the number of sides. So you don't necessarily need a formula for that one. All right, now we are finally into the examples. Example number 1. Find the area of a regular hexagon inscribed in a circle with a radius of 4√3. This is geometry. This is K-level geometry. This is not middle school. This is not like, oh, we've been there, done that. This is the good stuff. So draw a picture to start with. Okay, hopefully I gave you enough time to draw the picture yourself. If not, press pause if you're watching this lesson. Here is what your picture should have resembled. We have a hexagon inside a circle. The circle has a radius of 4√3. So this right here is 4√3. Now we need to find the area. We know the formula is apothem times perimeter divided by 2. So we have some work to do. Is hexagon one of our special cases? Absolutely. We know that this angle is 120. And when 120 gets cut in half, you get 60 and 30. So what's across from the right angle? Okay, it's 4√3. So what goes across from 30? We need to half that. So it's 2√3. And what goes across from 60? Okay. X√3. So 2√3√3. So that's just 2 times 3. So we have now found the apothem. It is 6. I hope you're following me. So this equals, let's see, the apothem is 6. What's the perimeter? Well, half of the side is 2√3. So the whole side is 4√3. The whole side is 4√3. And how many sides are there? There's 6 sides. Apothem times perimeter divided by 2. So we are not going to plug the √3 in our calculator, okay? It's taking forever to show up on the screen. Okay, so when we go to our calculator, we plug everything in except for the √3. So I'm plugging in 6 times 4 times 6 divided by 2. You get 72. So the answer is 72√3 centimeters squared. It was a tough one to start off with because 4√3 was the hypotenuse. We should have started off with maybe just a whole number as the hypotenuse. Anyways, the apothem was 6, the side was 4√3, and the perimeter was 4√3 times 6 because there's 6 sides. Okay, let's keep going. Find the area of an equilateral triangle with a radius of 6√3 meters. So draw a picture, and then I'll show you my picture. All right, hopefully you drew a picture. You drew an equilateral triangle, and you drew a radius. The radius is this segment right here. So the radius is 6√3. Once again, we have this √3 across from the 90. Goodness, I don't know why. Okay, so anyways, let's make sure we put the 30 and the 60 in the right spot. I would never put the 60 here because that's not the whole angle. So make sure you know that 60 gets cut in half. So this is 30, and then here's our 60 right there. So 6√3 is the hypotenuse. Cut that in half. 3√3. That goes across from 30. 3√3. And then what goes across from 60? Well, it's x√3. So 3√3√3. We love that because they cancel. 3 times square root of 3 times square root of 3 is 9. 3 times 3. So this is 9. Be careful. 9 is not the side. 9 is half of the side. So make sure you're careful about that. All right, formula. Apothem times perimeter divided by 2. The apothem is 3√3. The perimeter is, let's see, side times the number of sides. Each side is 18, and there's 3 sides. divided by 2. Don't forget the divide by 2. Don't do all of that work and then forget to divide by 2, okay? So in my calculator, I do 3 times 18 times 3 divided by 2. The answer is 81 root 3 meters squared. Guys, let me show you something really quick because you're not the only one to assume this. This right here is the apothem. This is the height of the triangle. The height is not the apothem times 2. No, it's not. Because this from here to here is a radius because it goes from center to angle, and this goes from center to side. So the height of an equilateral triangle is not 2 apothems. It's actually an apothem and a radius. So I would not do base times height divided by 2 if you're given the radius. You have to do apothem times perimeter divided by 2. You don't have to be inscribed in a circle to have a radius, but we could have inscribed it in a circle. Regular polygons have radiuses whether or not they're in a circle. Good question. Find the area of a square with radius 4. This is one where I wouldn't use apothem times perimeter divided by 2. Actually, for a square, I'd probably never use apothem times perimeter divided by 2. But you could. Here's our square. The radius is 4, so just be careful where you put your labels. Radius goes from center to angle. The radius is 4, so find the area. All we need to find an area is a side. Let's just find a side, okay? So 4 is across from 90. I'm trying to think of the easiest way to show you. I would actually do this. I would do this. The radius is 4, and the diagonals are perpendicular. So 4 root 2. Are we okay with that? 45, 45, 90 triangle. That way I'm not having to divide by root 2 and then it gets messy and we would just undo it. And so 4 root 2. 45, 45, 90. Yep, so side squared. 4 squared is 16. Square root of 2 squared is 2. That wasn't so bad. 32 square inches. Could we have gotten that doing apothem times perimeter divided by 2? Sure. It would just be a little bit longer. Okay. What's the area of a square circumscribed about a circle with a radius of 16? This one is really important. Watch me, okay? So, the square is outside the circle. So I need the square to be outside the circle. The circle has a radius of 16. Would that be a good radius to draw? Would that radius help me solve this problem? No. So be careful, that radius doesn't help me. So I'm going to erase that and learn from our mistakes. I'm going to draw this radius of my circle. Now, since the circle's inside, the radius of the circle is actually the apothem of the square. The radius of the circle is the apothem of the square. Anyways, all we need to find the area of a square is a side. Side squared, right? How long is the side? This is one where you can assume that the apothem is halfway, both ways, okay? So if that's 16, this is also a radius, it's 16. So the side is 32, and you simply square the side. Are we okay with this? 1,024 squared feet. I have to show you one more, and then we'll go over those questions y'all were asking. Okay, this is the last one. We'll have to do these later. Yeah, okay. Last one. This one's important because this one's different. Find the area of the regular polygon to the nearest tenth. What kind of polygon is this? That's a pentagon. Now wait a minute. Miss Tanton didn't put pentagon on the special cases page. Okay, so since this is a pentagon, we're going to have to do something different. This is not a special case, so this is really important. The radius, the apothem is 6. You need to draw in the radius, and we need to find the radius. Now, we need to know the angles. And guys, it's not 30, 60, 90. It's not 45, 45, 90. So, how do you find the angle of a pentagon? Well, what did we do earlier? N minus 2 times 180 divided by N. Instead of N, we put 5 there. Okay? So 5 minus 2 is 3 times 180 divided by 5. So each angle is 108. We just found the angles. Now, to find this angle right here, we need to do 108 and we need to bisect it. Yes, you can assume that the radius bisects the angle because it's regular. So this is 54. Guess what you're going to have to do to find the radius? What? Yeah, Taher got it. Trig. I'm sorry, but you have to. So, that's okay because we are awesome at trig. Okay, so we double it. So this one's going to be tangent. You'll need radiuses other times, so it's good that we found it. Tangent of 54 equals opposite over adjacent, I'll call it x. Denominator divide, 6 divided by tan 54. And we get 4.359. We're going to double it times 2. And we get 8.7. I'm going to write more decimal places than that. That is one of the sides. Now, let's multiply it by 5 and find the perimeter. I'm keeping this all in my calculator. Times 5, 43.59255. Okay, now I have the perimeter. Now I'm going to do times 6, because that's the apothem, and then divided by 2. I didn't write anything down in between. I kept all of it in my calculator so it could be as exact as possible in the end. So, final answer, 130 point, here's 10, 130.8. Did y'all get the same thing?